Hello AP Chem, I'm here and we're going to do a butane lab, and the goal of this lab is to collect butane gas over water, and we're going to do that by going through some water displacement. I have a setup here where I've already inverted a flask, so you can see here the flask is filled with water and it's upside down, so as I lift it up no water is escaping, so I'm going to keep this underwater. And I'm going to bubble gas into this container. The way we're going to calculate molar mass is we need to collect some data. So we're going to be using this setup to mainly collect the volume of the gas. And what else we can measure is as we bubble this butane fluid out of this lighter into the container, we're going to notice the mass of this lighter decrease. As we use up some gas, this lighter should weigh less. So I'm going to use a scale to measure the mass difference before and after. And then we can measure the air pressure in this room, we can measure the temperature of the system, and using all those variables of the ideal gas law, we should be able to determine the experimental molar mass of butane lighter fluid. We have the formula for butane gas right here, which is C4H10, which is a carbon chain molecule. This is a 4-carbon alkane, which is an organic naming system. The alkane are these long carbon chains. So butane is heavier than air, and so it's more dense than air. So it's not actually going to rise. It's actually going to sit in this flask pretty well, and we'll have a nice little fun end to this lab where I set it on fire. So I'm going to show you the procedure for collecting the gas, but first we need to measure the initial mass of this. Now I'm going to be holding this underwater as I release the gas and collect it. So when I'm done with the lab, or done with the procedure, the lighter is going to be wet. So my initial mass needs to be based on the idea that the lighter is going to be wet afterwards. So I'm just going to get the lighter wet, hold it in water, I'm going to move it around, and I'm going to take my initial mass the same way I'm going to take my final mass, where I've shaken off some water. So I'm going to standardize how many shakes I'm doing. I'm going to wrap this in a paper towel, and I'm going to shake 1, 2, 3, 4, 5, turn it over, 1, 2, 3, 4, 5, and I'm going to do the same thing at the end of the lab. Let's go over to our scale and measure the mass. I've already zeroed it out. The initial mass is 13.658 grams. All right. I'll show you what this looks like really quick. Here's the empty flask, and we're going to fill this complete with water and get all the air bubbles out. And then I'm going to just go ahead and invert it. And I'm going to hold the lighter underwater and just hit the black switch to open up the gas line, and I'm going to catch the gas coming up into the flask. And I know you can't really see this on your end, but I'm collecting gas, and you can see the bubbles, hopefully see the bubbles forming at the top of this flask. I'm going to go ahead and fast forward a little bit so we can get to the end of this procedure, because this one takes about 10 minutes. Okay, I'm almost done collecting the gas. I'm going to be really careful not to spill any. And you can see that the water line has moved down considerably, and all of the gas from the lighter is now trapped inside the flask. This is called water displacement. As the gas comes in, it's going to push the water down. Pressure builds up inside the flask, and it's able to push the water back down, and we're going to stop when the water line outside is the same as the water line on the inside. At that point, we can assume that the external pressure is equal to the internal pressure, and that's how we're going to approximate the pressure of the gas on the inside. I'll go ahead and keep collecting gas. You can see it bubbling up. I'm going to try and collect as much as possible. Not only will that make a fun end of the lab demonstration, but it makes our data more accurate. Now there's going to be a little bit of water left in here. I'm not going to be able to remove all of the water. If I do, I'm run the risk of losing some gas to the outside. So we need to have a way to measure the volume of the collected gas in this flask. And I'm almost done. I'm going to stop right about there. That's good. And I'm just gonna redo the lighter in just a moment. I'm gonna leave it out, but I'm gonna re-soak it in just a moment. So the pressure on the inside is equal to the pressure on the outside, assuming that the water levels are the same. And there's a little bit of extra room at the top of the flask that's not being measured, that's not considered the volume of the gas, because there's extra water in there. And the lines on the flask stop here. So I'm going to give us some measurements for the total volume this flask can contain. I'll have to use some water to measure that. And then I'm just going to subtract off that little bit of water that's left over in there. To make sure that nothing falls out, and I need to make sure I need to keep everything, I'm going to use a plastic dish and collect the remaining water in there. I'm gonna go set that down and I'm gonna reposition the camera. We're back. So I let this sit for just a little bit and I was able to take the temperature of the classroom, the air in the room, which we can assume because it's touching this flask, the temperature of the gas inside the container should be about the same as the temperature outside the container. So we are making a little bit of an assumption with that regards, but that'll be accounted into the error associated with the procedure of the lab. When we do these kind of experiments, there's going to be some natural sources of error, and that's probably one of them. We're just making an assumption that the internal temperature is the external temperature. So I have the temperature right there. And I also looked up the air pressure in Fair Oaks today, and the website gave me 30.24 inches of mercury. And so we have a conversion of inches to millimeters, because we're going to have to convert that to millimeters of mercury. So we are able to measure the temperature, the pressure, we are going to have mass value in just a little bit, and we need to account for the volume. But first, let's have some fun. I'm going to have a beaker here to collect any water that may fall out, but I'm going to go ahead and set this butane on fire. The butane is a slow burning gas as opposed to its close cousin, methane. Methane is much lighter and very explosive. Methane comes out of these gas lines. But if we extend the carbon chain out, we have a heavier molecule that still releases a lot of energy, but just burns slower. And if we double this, we get the fuel that's in cars, gasoline, octane. And there's a little heptane, and the configuration is not perfectly linear for the octane that they use in cars, but octane burns even slower, which is nice so your car doesn't blow up. All right, let's check. I'm gonna tie my hair back just in case, because I normally don't have to deal with that. But my COVID hair is strong right now, so let's just take all necessary precautions. Check the, okay, that looks good. So I'm going to go ahead and pick this up and invert this. Keep all the water. So there's a little bit of water left in there, and the gas is pretty heavy, so it's not actively escaping, but I can light it on fire. And then I can just pour it out. Pretty cool. And I need some water fell out, so I'm collecting that, because I do need to measure that water that left out. But you can see how slow it's burning. And it's kind of starting to travel down the flask, but as I pour it, it burns pretty readily. And I know people used to do the lighter trick where you collect the gas in your hand and you ignite it, which you shouldn't do, by the way, because that's dangerous because it's in your hand. It's really dumb. But at least this way we get to experience what it's like while being safe. We being me. Normally I'd let you guys do this, but too bad. Let's go and see if there's more in there. There's a little bit left. There's still a little bit of flame going. There we go. You can see that it pours out. I think that's all of it. So what I'm going to be doing is measuring. I'm going to fill this up completely, measure how much water this can contain, and I'm going to subtract off the water captured here. I have some graduated cylinders to help me measure that. So let's start with, this should contain most of it. Good, I eyeballed that correctly. It's just less than 20 milliliters. So I'm gonna get down and measure this. Just under the 20 line, so if I'm reading the meniscus, it is 19.50. Go ahead and write that on the board. And remember, I'm able to measure to the hundredths place because each of the tick marks is the tenths place, so I estimate one place value after that. It's about halfway in between. So there is one part of the slab that we do need to consider, is that we have our water line right here, and we've collected gas in this container. Now we've been saying that this is butane gas, but because we're collecting it over water, water is a volatile liquid, meaning it evaporates. When you say something is a volatile liquid, it will have some evaporate. So based on the temperature of the water, we can determine approximately how much water vapor pressure is in the container. And there's a table of values that you're going to reference to get that. So I'm also going to include the temperature of the water in our calculations. And we'll have to subtract that pressure of the water vapor off of the total pressure that we determined for the gas inside, which was the measured pressure of the air. We're going to subtract off the water pressure so that we are having a more accurate representation of just the pressure from butane inside the container. Most exciting part. I'm just going to measure this water. So I've filled it up completely, and I'm going to pour it in here. So there is 100. We'll go again. There's 200, and it should be just less than 300, but it's going to be close. Okay, so that's 300 right there, and let's figure out what's left over. 300 and... looks like that's 16, a little less than 16. So I'm going to say 15.90. The last thing I need to do is measure the mass of the lighter. So I just dipped it in water again. I'm going to do the 5 shakes each direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and I'm going to go ahead and measure the final mass of the lighter to see what mass of the butane was actually collected and left the lighter. Okay, 12.94. Let me go write that down. .940 grams. So this is going to be my first trial, and I'm going to use this final mass as the starting mass of my next trial. I'm going to do another one really quick, and I will be posting that data as well. So we'll have 2 trials to calculate the experimental molar mass of butane.